Okay, so today I'm taking a look at Ka and Kb and their connections with Kw and how to use it in some old diploma questions. So this first question, you get some information about penicillin. You can see from the equation given it's in equilibrium. You also are told that it is an acid and you know the concentration. You also have the pH. So the first question here is just showing that you understand the definition. So equilibrium occurs when the rate of the forward reaction is equal to the rate of the reverse reaction. So even without reading this information about penicillin, we should be able to do that question. This next one, talking about the strength of about Ka, well, until we actually figure that out, we're not going to know. My assumption is it's a weak acid, but until we calculate the Ka, we can't tell for sure. So if it is a strong acid, it would have a very large Ka. If it's a weak acid, our Ka is going to be small. So we can actually calculate it, and the Ka formula is the concentration of hydronium squared divided by the concentration of your weak acid, subtract the concentration of hydronium. So this is the formula we want to use. We want that connection that you know the concentration of the weak acid, so we can fill that in. And if you know the pH, then the concentration of hydronium is 10 to the negative pH. So we can plug everything in because now we would also know the concentration and find Ka, and you will find that the Ka value is less than 1. It's, I think I calculated it to be 0. Let me see here, 0.00 something. I'm just trying to find it here. 0.00176 is what I found the Ka to be. So it's very small, so we can describe this as a weak acid with a Ka value less than 1. So that's our first bit, just looking at and dealing with the formula. This formula is not in your data booklet, so you do have to have it memorized. This next one is asking about the pH of propanoic acid. So this is another one dealing with the Ka formula. So you have the hydronium ion concentration squared divided by the concentration of the weak acid minus hydronium. It's concentration. So one thing we talk about in class, that weak acids dissociate less than 1%. So this value for hydronium will actually be very, very small. And if we want to find hydronium, because it's so small, you can ignore it in the denominator. So I tell my classes, if you have it, use it. If you don't have it, then you can ignore it in the denominator. The other part that would be missing is your Ka value, and that you just get from the data booklet. So I would look up propanoic acid, which is right here, and get the Ka value. So filling some information in, we have 1.3 times 10 to the negative 5 will equal the concentration of hydronium squared divided by the concentration of the weak acid. So if we've set it up, now we just need to solve. So we'll take that value of 1.3 times 10 to the power of negative 5 and plug that into our calculator. We'll multiply that by the value of 0.13 because we want to get that out of the denominator. So we'll do that next. I think I've got to do this one more time. 1.3 times 10 to the negative 5. Then I'm going to multiply that by 0.13. And I get my answer here. And then I want to take the square root of that number and see what I get. But my answer didn't carry over, so of course it can't be that easy. Thank you for waiting here with me. Times 0.13 equals. Okay. So I'm getting the value 0.0013 once I square root both sides. So when I'm looking at something, so that would just be the concentration. So the next thing I want to do, because I'm like, something looked a little bit off here, but if I want to actually calculate the pH, I have to do the negative log of the hydronium's concentration. So if I calculated this correct, I'm just putting that now into my calculator with the negative log and seeing what we get. So let's do that. So I'm just trying to get my log value. negative log of 0.0013. And to keep 2 significant digits based on this value for pH, that would be 2 points after the decimal. I'm getting 2.89. So I'm going to double check that, and hopefully I don't have to redo this part. So let's move on to the next one. The next one is just showing you understand Ka values. And if you look at your data booklet and the last value or your column of the data booklet, Ka, you have the largest values up top. And then as you move down your data booklet, they get smaller. Smaller. And now the larger you are, the stronger you are in terms of Ka. So your strongest acid would be at the top, and then as you go down, it gets weaker. So when you're looking here above list, or K's given, first we want to notice they're not in order. And if we want from strongest to weakest, you want your largest value going down to your smallest value. So your strongest would be number 4, and then we would have number 1, and then number 3, and lastly number 2, which is the most negative. So that's that one, just making sure you understand the order. Going from this one, moving on now, it's Kb. The main formula for Kb is similar to Ka, except instead of dealing with hydronium, you're dealing with hydroxide. And instead of dealing with a weak acid, you're dealing with a weak base. Because this formula has also come from the ICE chart, same idea, this value in the bottom is very, very small. So if we have it, we use it. If we want to find it, then we can ignore it in the bottom. Now, this question, you get some information of hydrofluoric acid telling you that it's a weak acid. And we know it's weak. We can also see it's below the gray line from your data table. So hydrofluoric acid is right here, and the Ka value is given. Now, this one is just asking you what is the Kb. So the connection between Ka and Kb, we'll use this on the next part, but the connection between Ka and Kb is when you multiply them together, they equal to Kw. So if we know what Kw is, which we do, and you know the Ka, which you do, you can rearrange this to solve for the Kb. Now, when you put this into your calculator, you're going to divide both sides by your Ka to get Kb alone. If you're doing this in just one step, just make sure to use brackets. So I would have 1.0 times 10 to the negative 14, and I want to divide by, keep in brackets, 6.3 times 10 to the negative 4. Plug that in, and I'm seeing the answer 1.587, which will round to 1.6 times 10 to the negative 11. Now, I believe this is our last question, and this one is talking about ammonia, which is a base. If you do not have OH in the formula, then it is a weak base. So we can rule out the last two because this is weak. And then asking about the concentration of hydroxide ions, we're going to have to solve for them. Now, just like when we were in Chem 20, if you're dealing with a base, you need POH. So because you have pH, you can take that away from 14 to have POH. So we'll quickly do that. So 14 minus 8.10 is 5.9. And then we're going to use the formula Kb equals, and we have Kb equals the concentration of a hydroxide ion squared divided by the concentration of the weak base minus the concentration of hydroxide. So looking at this information, statement below, we can find Kb, and we have OH. So we are figuring out the concentration of the weak base. So when we're looking at this question, and I just realized I didn't copy and paste the ammonia Kb value. So let's just look that up quickly. So I'm just looking up the Chem 30 data booklet so that I am able to look at page 8 and 9. And when I look at page 8 and 9, I'm looking for ammonia. and that is going to be at the bottom of your data booklet. So I just have this, I'm just looking for it now. So from page 8 and 9, I see that ammonia has a Ka of 5.6 times 10 to the negative 10. So what we want to do first is get that Kb value so that we can plug it in to the formula. And then we also have the OH numbers, and now we can rearrange to find the weak base. So let's plug this into our calculator like we did before. We know that Kw equals Ka times Kb. So let's figure out the Kb. So going up here, we have 1.0 times 10 to the negative 14 equals 5.6 times 10 to the negative 10 times Kb. Getting Kb alone, so we'll plug this into our formula. So 1.0 times 10 to the negative 14 divided by, and keep this in brackets, 5.6 times 10 to the negative 10. Okay, so this is our first one. Don't round too early. Keep this in your calculator. This is 1.7857. That number is going to keep going, times 10 to the negative 5. That's what your Kb equals. Okay, so we're going to keep that there, and we're going to now relate it to the rest of it. And if you wanted the Wb alone, your weak base, we just have to rearrange that. So if we rearrange that, that would become your weak base equals the concentration of hydronium, sorry, that's hydroxide, squared, divided by the Kb, and then we would add on that OH one more time. So that's how we're solving for the weak base. So let's do that now. So we have the Kb, and we have the concentration of hydroxide. So we can figure that out by going 10 to the negative POH, and that will equal your hydroxide's concentration. So we'll have 10 to the negative 5.9. I'm plugging that into my calculator. I want to square this value. Then I want to take it and divide it by my Kb that I have to keep in brackets. So 1.78, and I would keep that value in my calculator and just carry over that answer, times 10 to the negative 5. Get that answer. And then lastly, we want to add on 10 to the power of negative 5.9. So I'm seeing here 1.3, and I would round the last one to 5, but we're good there, times 10 to the negative 6. So luckily I see my answer, so that's perfect. I hope you found this helpful. If you did, please like and subscribe. And if you have any comments or would like me to do a certain video, please leave me a comment. Thank you for watching.